So we're on now to question 9. Question 9 is a sequences and series question. A competitor is running a 20-kilometer race. She runs each of the first 4 kilometers at a steady pace of 6 minutes per kilometer. After the first 4 kilometers, she begins to slow down. In order to estimate her finishing time, the time that she will take to complete each subsequent kilometer is modeled to be 5% greater than the time she took to complete the previous kilometer. Show that the time to run the first 6 kilometers is estimated to be 36 minutes and 55 seconds. So this is a classic context and applications question. You know, the maths of this is not that difficult. However, you have to read this question a few times to make sure you're getting it right. So the first 4 kilometers she runs at 6 minutes per kilometer. So it's 4 by 6 is 24 minutes for the first 4 kilometers, for the first 4 kilometers, yeah. But then her 5th kilometer will be 6 minutes multiplied by 1.05, and then her 6th kilometer will be 6 minutes by 1.05 times 1.05. And when you put that together, it's 36.915 minutes. But of course, we want it in minutes and seconds. So what do? You take the 0.915 and multiply that by 60, you get 54.9 seconds. And then their time is 36 minutes and 55 seconds. Now there's 10 marks for that. And once you see it, they're easy 10 marks. But we know from experience, sometimes students do struggle to get full marks there. By forming equations for the 5th, 6th, and 7th kilometers, show that the estimated time in minutes to run the nth kilometer for 5 less than or equal to r less than or equal to 20 is 6 by 1.05 times r to the power of r minus 4. So what do? Well, we know that the 5th kilometer is 6 times 1.05 to the power of 1. The 6th kilometer, the time taken will be 6 by 1.05 to the power of 2, and the 7th kilometer is 6 by 1.05 to the power of 3. Therefore, your nth kilometer would be 6 times 1.05 to the power of r minus 4, because just if we're looking at the 7th one, it'd be 6 times 1.05 to the power of 7 minus 4. And the 7 minus 4, of course, giving you the 3. Okay. So that was 5 marks. And again, very straightforward when you know how to do it. Using this, find the time it takes in minutes and seconds to complete the 18th kilometer. Now, this is very straightforward because you're just subbing in 18 for the R, and you get 11.87. And again, we want to put this into seconds. So it's 11 minutes and 53 seconds. And there's 10 marks for that. So nice and straightforward. Now we want to draw a graph to show her total distance traveled through the race. So we're just going to get a number. We're going to go up in every 5 kilometers, and then how long did it take? So one thing here that is a little counterintuitive is typically our function has time on the horizontal axis and then distance on the vertical axis. This is the other way around, okay? So we're showing it the other way around here, that the distance is our independent variable and the time is our dependent variable. So you can work it out for these blocks 5, 10, 15, 20, and you can see that after 5 kilometers, it has taken her 30 minutes and 30.3 minutes, and for 10 kilometers, 66.85 minutes. For 15 kilometers, 113.5, and for 20 kilometers, 173.04. So the graph looks like this, and that's 10 marks. Calculate the estimate of the total time in minutes and seconds it will take her to complete the race. So in this case, we know that her first 4, so this is our first 4 kilometers, and the first 4 is that 4 times 6 is going to be 24. The rest of this is a geometric series. In this series, the first term, this is term one. Term one is going to be the A. So that's 6 times 1.05. Term two is 6.6 times 1.05 to the power 2. So R will be term 2 divided by term 1. So that'll be just 1.05. And the N, there are going to be 16 terms in this particular sequence. So N is equal to 16. So the sum of those 16 terms is the 149.04. The total time then is your 24 minutes plus the 1.04. The 24 plus the 149.04. So it's 173.04. And yet again, we need to change this into minutes and seconds. So you just got to be careful. You multiply the 0.4 by 60 and you get 3 seconds. 10 marks for that. And then our last 5 marks here is going to be explain why this is not a convergent geometric sequence. So why is it not converge to a finite total if k goes to infinity? And the reason is it's not a convergent geometric sequence because the modulus of r is greater than 1. So because r is equal to a 1.05, what happens is, we saw the shape of this curve earlier. It goes off like this and heads off towards infinity. So as k gets larger, as k gets larger, the sequence gets larger. And you could say as k goes to infinity, the sum goes to infinity. The sum of the first infinite number of terms heads to infinity. So the sum to infinity does not converge to a particular value. So therefore, it's not a convergent series. And that was 5 marks. Okay, we're on to our final question, question 10.